Hello and welcome to Hydrovar X training. I'm Josh Kingsley from the Xylem Industrial Marketing Team and also your facilitator today. We are live from the Little Red Schoolhouse at our Morton Grove facility. Key reminder, this is meant to be interactive, so please ask all the questions that you want via the Teams chat. As a best practice, please follow the training on the YouTube feed using Teams for questions only. I, along with Sarah Bonham, who is also part of the Xylem Industrial Marketing Team, will make sure that all questions are asked and answered on the live stream. And with that, I turn things over to Derrick to kick us off.
Thanks, Josh. Hi, everyone. As Josh mentioned, I'm Derrick Oberdorf, the America's Product Line Manager for Monitoring Controls. Today, we will be discussing our new product called the hydrovar X, which is a motor with an integrated VFD. As Josh mentioned, please feel free to send any questions you have throughout the presentation. He'll interrupt me and I'll get them answered as we go along through the presentation. Here, just some of the topics we'll be covering throughout the presentation, kind of a high-level agenda here. But just to help you guys, understand some of the industry trends we've been seeing, some of the problems customers have faced, and ultimately what led us down the path of developing hydrovar X. Obviously helping you understand what products hydrovar X will be paired with in the future or as of today, awareness of how the technology works, understand how to install, commission the product, configure it, so on and so forth. So to kick off, these are some of the macro market trends that we have noticed in the market through speaking with customers, distributors, so on and so forth. These four high-level ones. First, starting with integration. Everyone wants lower installation and commissioning costs with an integrated design. A lot of this comes pre-built right out of the factory for you. It's pre-wired, pre-programmed, so eliminating a lot of that work out in the field, time and money with, you don't have to purchase wiring, long leads of cable between VFDs and motors. It's all compact and together there. Nice smaller footprint with that integrated design. And even a simplified supply chain. So now you're buying everything from a single source, and rather than buying 3-4 different part numbers being a pump, motor, VFD, you're now buying a single part number, getting all of that together. The next one is efficiency. This is a much bigger topic on the global scale, especially over in Europe where there's new regulations in the pipeline requiring the use of VFDs with any pump or motor 5 horsepower and above. We're not quite there yet here in the US. However, it is something that we tend to follow suit 3 to 5 years later down the road. So we are just getting ahead of this trend and we'll be prepared when that happens in the future. But obviously, still people like to take advantage of more efficient products. There are energy rebates that could be taken advantage of as well. Next is intelligence. So historically, I think customers tend to get overwhelmed with variable frequency drives. They do love the benefits that they bring, but they can be very overwhelming to users, or there's thousands of different parameters and settings to go through. So they do want that intelligence, but they want it with an easy button or as simple as possible. And not only from a startup and configuration standpoint, but they also want some condition monitoring there. So what is the health of my system? If there is something wrong, how do I take action to correct it as well? And then lastly, connectivity. This has been a big topic over the last few years with remote workers or less workers out in the workforce. They want to just be able to log into a mobile application or their computer, pull up an application website, and check in from afar the status of their assets. So they can just quickly get that peace of mind without sending somebody directly to site to look over pumps and products. Here I like to just focus on the blue box there in the center of the screen, some of the everyday challenges and pain points customers are facing in the market. First is just poor situational awareness. Even if you are an expert, it is very difficult to identify problems before they become a crisis. And it tends to be too late by the time you notice, right? An asset has failed, now it becomes an emergency. There's downtime, you need stuff ASAP to get it fixed. And then lastly, retiring workforce. We are seeing kind of a shift in that labor force where a lot of the previous generation are retiring, newer generations moving in, and there's a lot of system knowledge lost, or what I call tribal knowledge, where the veteran workforce out there had a lot of these information in their mind. It's not necessarily documented, and it's not being passed along. So that's just leading to that system knowledge loss I was talking about. So how are customers facing that? We're seeing 3 times faster growth in the digital water space compared to the conventional water technologies that we typically see. So rather than passing that knowledge on, they're moving to that digital water space to fill these gaps or challenges and pain points. Here's just some of the value that smart connected products bring to our customers. First is asset management. Right now in a mobile application or a database, you have what you have, where your equipment is, when it was installed. A lot of times, the beginning of conversations on the phone with tech support is just figuring out exactly that. What does a customer have? Where is it? A lot of times nameplates are worn, literature's thrown away, and it just takes a lot of time in those conversations to just figure out what we have. Now we eliminate that. Like I said, it's pulled up right in a mobile application. You get that information right away, and we can get right to helping you over the phone. Next is startup and operation manuals. Once again, stored with a click of a few buttons. You don't have to save manuals. You don't have to dig through websites, get lost, struggle to find it. Just with a couple clicks of a button, you can pull up exactly what you're looking for. Energy optimization, just all around reducing life cycle costs. And then as we touched on, condition monitoring. So what is the health of my equipment? And then taking that a step further, not only notifying that there's something wrong, but what is wrong and how do I fix it to get it back up and running properly. With that said, that led us to some high-level innovation strategy at Xylem. You can see there in the red box in our intelligent solutions or monitoring controls group, we are focusing on integrated motor VFD technology. And then the box to the right is digitalization as well, which is around that condition monitoring space. A separate product called Optimyze, which it measures temperature and vibration to give you some early warning indications of potential failures. High-level roadmap. We've gotten a ton of feedback throughout the years. We have almost 10 different VFDs that are out there. They all look and feel different. They use different terminologies. So if you're an expert in one, it doesn't necessarily mean you're going to be an expert in them all. And it's kind of overwhelming, even to our internal resources in tech support, to become experts in all of these different products. So we want to consolidate and have a common user experience, user interface across the board. So now if you're an expert in one of our products, you're going to be an expert in them all because they're going to have that same exact look and feel. And then that goes similarly with our mobile and web applications. So if we do have multiple mobile applications or web-based platforms, they all, once again, are going to look and feel the same, just giving that commonality across all of our platforms, truly helping, I think, our internal and external customers support these products, get them up and running, and troubleshoot them. So here, this slide is basically a reiteration of the previous one, just giving you detail. On the left-hand side there, you can see some of our current products that's showing 7 or so. The idea in the future is to consolidate those down to 4 or so different platforms. But if you look at those 4 different platforms, they all still have that same user interface, user experience. So once again, if you're an expert in one of them, you're going to be an expert in them all. So it's just giving you that consistent customer experience. And that also helps us from a supply chain standpoint. If we're leveraging some of the similar building blocks, it gives us a more robust supply chain. We can leverage economies to scale, drive down costs, and be more competitive in the market. And then lastly, just consistent design also allows us to more efficiently use our engineering resources. If we're giving them some of the same building blocks to go off of, now they have a commonality to start with, and we can continue to stay ahead of the curve, bringing new benefits to customers. Jumping into the hydrovar X, so a bit of a mouthful is the full name here. It's a permanent magnet assisted synchronous reluctance motor with an integrated variable speed drive. It will go from 4 horsepower all the way up to 30 horsepower. Like I said, we're just expertly pairing this with our flagship pump products. So all the pumps that you are familiar with and use today, you would still be using them, but we will be incorporating this motor with an integrated VFD to those pumping solutions. So range overview, there will be 2 different input voltage ranges. It's 200 to 240 volt or 380 to 480 volt with a plus or minus 10% tolerance. It's 3-phase input, and they are dual hertz, so 50 or 60 hertz rating. It's a bit backwards from what we're used to seeing out in the market today, where the different input voltage ranges is due to the motor. There's two separate motors. There's a 200 to 240 volt motor or a 380 to 480 volt motor. The VFD actually does not care. It can support all the way from 200 to 480 volt. So there is strictly 3 hardware part numbers essentially for the VFD itself. There's a size B, size C, and size D that cover the whole range. So it just helps us from a stocking level standpoint, or even our customers, if they want to stock things, there's just simply 3 VFD part numbers that they would have to hold on their shelves to support replacements or anything of that nature in the future. Speed range, 800 to 4,000 RPM. And then this is a TEFC motor enclosure with a NEMA 4 outdoor rating VFD on it, so it is outdoor rated. And then this temperature rating is actually ambient temperature rating, anywhere from -4 to 122 degrees Fahrenheit. So you can see here, size B supports anywhere from 3 or 4 horsepower to 7.5. Size C will kind of blend 7.5 to 15 horsepower. Size D, 15 to 30 horsepower. And then we do have a planned size A, which would be 0.5 horsepower to 3 horsepower coming in the future. We do have a product in that space today called the ESM. It's a little bit of a different design, and the idea is to bring that technology up to speed with hydrovar X, and we'll have that single hydrovar X across the complete range from 0.5 to 30 horsepower. But specifically speaking, hydrovar X, we're 4 to 30 horsepower as it stands today. Some feature overview. There's a color graphical LCD, which we'll jump into later. We'll show you and mess around with the software programming parameters, so on and so forth. You can use a mobile application associated with this called Xylem X. We can support multi-pump applications up to 8 pumps without the use of an external PLC. Control modes, a ton of different ones: constant speed, constant pressure, proportional pressure, whether it's linear or quadratic, constant flow, constant temperature, differential temperature, and even, it's not listed, but differential pressure as well. Communication, this will come standard with Modbus RTU and BACnet MSTP, and it does have some Bluetooth communication capabilities, and that's all around the mobile application where you can connect via your mobile phone via Bluetooth, which we'll dive into that a little bit deeper later. Coming soon, so there are going to be different communication protocols available. You can basically purchase what's called an AnyBus module, and they support really any protocol that's out there on the market. Like I said, it's just coming standard with Modbus RTU or BACnet MSTP. If something else is needed, it would require you to buy one of these AnyBus modules and install it out in the field. So here in the top left, just looking at primary markets, primary applications. Once again, you're already familiar with using our pump products. The pump products aren't changing. So any of the markets or applications you're used to using our products in, that's going to remain the same. So whether it's industrial, commercial buildings, water utilities, water boosting, HVAC, whatever it may be, it's still supported. Bottom left is just some images of the competition and what their integrated solutions look like. And then the right is a kind of a perceived price versus perceived benefit chart. So historically with the Hydrovar Classic, which was that motor mounted VFD, it wasn't truly integrated. It was just a VFD set on top of a motor clasped to it with some brackets. We had what I would say was a high perceived price with a lower perceived benefit than some of the competition out in the market. With this new design, we shift our bubble essentially to the right. Now we have a much higher perceived benefit, and we found a way to keep our price very competitive, where I think our perceived price will come in even a little bit lower than what you would see out in the market with the competitors' integrated solutions. So some key differentiators. First is sustainability. So traditional permanent magnet motors and the majority of the competitors' design use a material called neodymium. This is very costly to extract, right? You have to extract large volumes of land basically to get very small portions of this. However, it is very, very radioactive and toxic, so it's harmful to human health and the environment. we found a way to not use neodymium. We are actually using a material called ferrite. Yeah, so giving us, a step ahead on the sustainability, right? Ferrite is not toxic or harmful to the environment or human health, so that is a perk with our design there. And also, aside from sustainability, 90% of the world's supply of neodymium actually comes out of China. So there tends to be a lot of trade, if there ever happens to be trade disputes, we could be cut off from this, or costs could fluctuate drastically. We are just avoiding any potential issues in the future there. Also, a lot of electrical vehicles are using the same material in electric cars, and those are becoming more and more popular, so it's a highly sought after material, and even that car industry is getting preferential treatment with that material. So once again, just avoiding many potential issues in the future from a supply chain standpoint and sustainability standpoint. Moving to the next bucket is efficiency. So the perks of neodymium was getting higher efficiency levels. So when using these permanent magnet motors with neodymium, we were able to reach IE5 efficiency levels. So today's standard induction motors are rated at IE3. So really any jump from IE3 to IE4 or IE4 to IE5 is a 20% gain in efficiency, which is very important and good. So we found a way to still hit those IE5 efficiency levels without using neodymium, which is a perk there. And then lastly here we have simplicity. As I touched on a few slides ago, a lot of customers get very overwhelmed programming VFDs. There's hundreds and hundreds of different parameters. It's easy to get lost or set something by accident and not figure out what you did wrong. So we really wanted to spend a lot of time here. We got, hired a third-party vendor. We got a lot of users in the room from various experience levels, and just looked over their shoulders and had them interact with electrical devices, software, kind of saw what was intuitive and natural to them, what they liked, what they didn't like, and designed our HMI and software around that. So I think you'll find that this software of ours is very, very simple and intuitive to use. We have had plenty of trainings to date, and the feedback has consistently been positive. So hopefully after today, although you won't get your hands truly on the product, I'll try to show you the best I can via camera here. You will find that similar thought, right? That it's very simple and easy to use. Some more differentiators, just a compact design. So the example I like to give is if you're looking at a 15 horsepower standard induction motor, the hydrovar X motor with VFD is the same circumference or even smaller than just the standard induction motor itself. So you are maintaining the same footprint or even smaller footprint, moving to this technology and adding a VFD to it. So just nice compact design there. And then serviceability is one where we stand out as well. A lot of the competitor's product, if the VFD goes bad or the motor goes bad, you have to swap out the entire unit. You can't just swap out the VFD or just the motor. We can separate the two units. So if just the motor goes bad, just the VFD goes bad, we can simply replace what is wrong. And you'll probably see in a couple other slides, but there's still no unwiring or rewiring of the VFD to the motor. There's a quick connection port between the two, so you're just undoing a few screws and you can pop that VFD off the motor. It's simply just a nice plug, so ease of serviceability there as well. So the reluctance motor, so I'll get into the rotor design there I think in the next slide. The middle picture here is the communication expansion modules. So that's where I was mentioning if you need something other than Modbus RTU or BACnet MSTP, you would buy that module and that's where you would swap it out there. It's that little gray box that's kind of hanging out of the VFD there. And then the far right is just that motor drive quick connection port I was talking about. So it may be hard to see on the screen, but it's kind of that little triangular piece there. It's just a plug, right? There's no wiring. It's all underneath there is the wiring, so you don't have to do anything. Here, I also like to point out the fins on the motor. So we have the fins there, and then on the bottom of the VFD heatsink, there's going to be a similar fin design. That's allowing adequate airflow from the motor fan itself to blow between the motor and VFD to keep it nice and cool during operation. So here are the three different rotor designs I like to go over. So the first one here on the far left is a permanent magnet rotor. That whole thing is that neodymium or permanent magnet material. As I touched on, right, supply chain can be very complex. There could be high fluctuations in cost and availability. And there's also a high impact on the environment and human health. However, the perk to using this, or the advantage, is lower energy consumption, or those higher energy or efficiency levels I was talking about. Then if we look to the far right, this is a typical reluctance rotor we have here. Some perks or benefits, right? We have a stable supply chain there. We know cost. There's very low environmental impact. We have taken a bit of a hybrid approach, as you can see here in the middle with our design. We are not using neodymium, but rather using ferrite, which is giving us a much more stable supply chain, keeping costs down, and there's very low or no environmental impact associated with that. However, we're still achieving those lower energy consumption levels or higher efficiency levels. So here, just some screenshots of the HMI itself and the mobile phone. So whether you're looking at the HMI directly or using the mobile app, they're going to look and feel the exact same. Whatever you can do on the HMI, you can do on your smartphone or mobile application as well. Here I'd just like to show, it's almost like a cell phone, where on the main home screen you'll see widgets where you can see valuable information, but you can also interact with those widgets to change some important parameters as well. You'll notice maybe the 4 dots on the bottom of the screen grabs. That means there's 4 different home pages with a set of different widgets and valuable information that you can take in or change. So 90% of the time, you may just scroll through these 4 main home screens and never have to dive into the sub-menu groups, just keeping it nice and simple and easy to use for our users there. And then the Xylem X app. So like I said, we can download the app. It's called Xylem X. It's available on Android and iOS devices. You would connect with your mobile phone via Bluetooth to the VFD. So it's basically just an additional display. If maybe you're installing this in a tight space and you can't lean over the VFD and get in there, or you just don't want to lean over the VFD, you can connect via Bluetooth. You can program it and operate it right from your mobile phone rather than right on the unit itself. Some other nice perks, you can generate service reports, you can download, upload parameters in a CSV file. So that's very important and a nice feature in my opinion, because if you can't figure out what's going on, you're trying to just dig through parameters and you can't get this to operate the way you think it should be, you can download that file, send it to our tech support team. They can take a look at it. If something stands out to them, they can manipulate the settings or that file, send it back to you to then re-upload into the VFD and hopefully correct any issues you were seeing out in the field. Then another perk is upgrading the hydrovar firmware. So if we ever release any new firmware in the future, you can do that via Bluetooth and the mobile application. You don't need a special plug to plug directly into the VFD or some special computer application to get that done. That is available. That would be another way to do it, but to keep things nice and easy, we're allowing it to be done via Bluetooth and that mobile application. So here we have 3 different apps. Like I said, the one associated with hydrovar X is the middle one there on the right. It's called Xylem X. You can go ahead, download that today. Register for it. We have a few others. There's the optimyze app, which is our condition monitoring sensor that gives temperature, vibration readings, so on and so forth. And then a Venzer, which we'll touch into, which is a standalone product to monitor VFDs or really any piece of equipment with Modbus communication. Just like to point those out, but once you register for one of them, or if you already have one and are registered for it, you use the same login credentials across the 3 platforms. So you don't need to re-register for all 3. Just note, if you download them, register once, use the same username and login for each one. Here's some quick instructions on how to connect via Bluetooth to the hydrovar X. So there's going to be what I call a multi-purpose button. It's basically 3 dots next to each other. You would long press that. It's going to put it in what I'll call pair mode or configuration mode. One of the LEDs should start to flash blue for you to let you know that it's in pair mode. You would pull up your Xylem X app, and it should let you know of any units that are near you. It's going to identify itself by serial number. You can see the serial number on the side of the VFD. There's a little nameplate sticker that would let you know the serial number. So you would click that. Once you do, a 6-digit PIN should show up on the hydrovar X screen, just telling you to confirm it on your mobile app. Once you type it in, it should make that connection for you, and now you can start to configure or operate the unit via your mobile application. You will have the ability to change the name of the unit after the initial pairing, so you don't have to remember serial number. You can name it by site or however you want to go about it to remember it. Here's a nice feature I like to point out, and we can show you on the hands-on portion as well, but there's essentially a built-in IOM in the VFD itself as well. So if you're navigating through parameters and you're just not quite sure what something is, I know different manufacturers of VFDs use different terminology for similar features, so it may not be something that's common to you, or it's something new to you. There's a multi-purpose button or information button that will give you a detailed description of what that specific feature or parameter does. So you don't have to call tech support or dig through an IOM or search on the website. You simply click a button and it's going to give you a much more detailed description of what that feature or function does. Here, so like I said, a Venzer is a separate product, but it is nice to pair it with a hydrovar X. This is a web-based platform that can tie into our VFDs via its communication ports. And what it's going to let you do is monitor a VFD from afar. So it can give you, pump status, operation points. You can even do some write capability, so you can start or stop a unit remotely, check what errors or alarms are there, and even change some set points potentially there as well. So it's just a web-based platform to monitor your solutions. I kind of call it a BMS Lite, right? It's all of your assets can be stored on this single platform, and you can monitor them here at a single dashboard, which is called a Venzer. Here are some screen grabs of some of the charts. So this would be basically the analytics tab, which is just taking a history of all the data points ever taken and putting them in graphical representation. So you can narrow or expand your search to whatever time frame you want to look at information in. But here it's tracking, right, energy consumption, the actual pressure of the system at that time, so on and so forth, the speed of the unit. Here would be the main dashboard here that you would look at, or live data, I'll call it. So this is a triplex hydrovar X example here. It's just showing you pump 1, 2, 3. You can see the status of each one. They're on, and then the third one would be running. You can see the speed that the third one is running in the bottom left corner. So just a nice web-based platform to check in on your equipment remotely. And then here is the main dashboard. So if you were looking at the main dashboard and you weren't in a specific station, it's just going to show you the number of stations you have, any active alarms you have, and then the bottom right is a map view just showing you the location of all of your stations that you have set up. So maybe you go here, and if you see no alarms, that's as far as you go. You don't necessarily have to jump into a station. If you're seeing an alarm, you can click it and get some detailed information on what exactly is going on. And here is just some screen grabs of some of our pump products with the hydrovar X technology on it. So that's a high-level overview of hydrovar X solution itself. So like we said, feel free to put any questions in the chat. We can go ahead and get them answered for you. But the next few slides here are just the pump products that we're introducing hydrovar X on. So we have the ESV and the EHM. These products fall under Gretchen Valentino's product portfolio. We are simply adding the X to the end of those names. So instead of just ESV, the ESVX or the EHMX are those pump products with the hydrovar X technology on them. So key features, just to go through this quickly, it's all the same key features that you're used to with the ESV, right? You're getting the same flow rate, head capabilities that you would traditionally, operating pressure, so on and so forth of the pump. We are just simply adding the hydrovar X motor with integrated VFD to the pump. So here are just some high-level family curves. This is offered anywhere from the 1 SV to the largest 125 SV. The only limitation with this is it's 4 horsepower to 30 horsepower. So if you find an ESV that requires something more than 30 horsepower, then we will not be able to use the hydrovar X technology with it. And similar with the EHMX, once again, the pump is the same as it's always been. So you're still getting flow rates up to 130 GPM with the EHMX specific products, heads up to 540 feet. Yeah, family curves here. This will be offered with the 3HM all the way up to the 22HM product range, 4 horsepower to 7.5 horsepower here, as the EHM maxes out at that 7.5 horsepower capability there. So the complete range for this product can use the EHMX. Then jumping to centrifugal product, the ESH. This would fall under Jimmy Wood's product portfolio. But once again, key features, you're still getting the compact close coupled design, optional mechanical seals, so on and so forth here. This is a little bit different. So you can see the curves here, maybe an adjustment looking at curves for the ESHX. So you'll see a 3600 curve, which it's labeled 100%. That is what we're used to seeing these pumps run at, but since this is a 4,000 RPM motor, we're giving you those 3,800 and 4,000 RPM curves. And then to the right, you are seeing the family curves there. There's 12 models. These are all pre-configured standard part numbers. So there's no building out different configurations as it stands today. We just have 12 models for you to pick from out of the portfolio. And then lastly, we have the package systems, which these fall under Jim Wilkinson. So we have the EHVX, which is similar to the EHV product you may be used to today. And then we're introducing a new one called the EHVXR. So general features, similar to what you're used to getting, right? It's a multi-pump skid, whether it's 2, 3, or 4 pumps on a single skid. Manifolds included. There'll be a single point power panel on the end, stainless steel, manifolds, check valves, so on and so forth. But much easier, brand new HMI simplified navigation compared to the 5th generation hydrovar that the original EHV packages used. So as I touched on, this is just the classic EHVX overview. It's directly replacing the existing EHVs. However, there is going to be expanded capabilities. So the EHV packages today max out at 15 horsepower configurations. They are taking advantage of the full 30 horsepower configurations, so we can get some more flow and head capabilities out of this new package with the hydrovar X. And then the EHVXR is a similar product. It's just a more compact design. So now instead of manifolds on the suction and discharge side or opposite sides of each other, the suction and discharge manifolds are going to be on the same side on top of each other, giving it a much more compact design. There's roughly a 30% footprint reduction. This is a great product for retrofit opportunities. If it's already a building that's established, we can fit through a normal doorway now with this package, where in the past customers would get frustrated if they bought a package. They would have to get it out in the field and end up taking off the manifolds and back on to get them through doorways. This helps eliminate some of that. Then lastly, we have sizing and selection tools. So there's a new sizing tool out there. Hopefully all of you are already familiar with it. It's called Xylem Solver. But all of these products are out there and available in the solver or selection tool right now. So, yeah. And then lastly, the only thing that's not out there, sorry, there's a caveat. The package systems are the only ones not launched. The ESVX, EHMX, ESHX are all launched and readily available today. The package system ones we just went through won't be available until about mid-August as it stands today.
And as a quick note, please do use that Teams chat to ask any questions. We're wanting this to be interactive, so please ask any questions about the content we've seen so far.
Thanks. And then just a couple more slides before we get into the hands-on portion. So here, I just like to touch on this. There's two different types of fault codes, I'll say. We call one an error, which here it's saying non-blocking. What non-blocking means is an alarm is less critical. That is some sort of fault that is not going to interrupt operation. It can still allow that pump or system to continue to operate. It's just notifying you there is something wrong and you should try to address it, but you're not, losing operation. There's no downtime associated with that. An error is a blocking condition, so that is a more critical fault, right? It is now shutting down the system to prevent any harm to the pump or motor or further damage. So that is going to require some sort of manual intervention to get that fixed before the system will be brought up and running again. To make sure there's no nuisance tripping, that error will actually reset itself a few times to prove that there's an error, and then it will, after a few failed attempts, it will truly shut it out and require someone to manually intervene. But there will be an alarm list built into the hydrovar X unit itself, or in our IOM, you can go look. Any alarms, which are those non-blocking, will start with an A followed by two suffixes. Then you'll have the name, description, and potential solutions to get that fixed. And then similarly, any errors which are more critical and shut down operation, they start with an E followed by a digit code, which have their own names, descriptions, and potential solutions associated with them as well. So those are all the slides for the overview portion. Maybe we can pause for a couple minutes to see if there's any questions before we jump into the hands-on portion of the training.
Once again, please feel free to type all your questions into the Teams chat, and we'll make sure that those get answered on the live.
Okay, while we're waiting, I'm going to power up one of the units, get that going.
All right, now that we have the drive powered up, we do have a question that came in. So Derrick, the question, is the hydrovar X motor intended to be used outside of the Xylem family? That's the first question.
There's nothing preventing you. It's NEMA dimensions where it can happen and it can be done, but to start, we are trying to avoid that, and the idea is simply to purchase it with our pumping products. But nothing is realistically going to prevent somebody from pairing it to a competitor pump, right? We just cannot then help you with what the pump curves or anything would look like using a competitor's pump product.
Next question, what is the expected delivery lead time for hydrovar X?
So as far as hydrovar X, the pump or the motor with the integrated VFD, we have several months worth of inventory on the shelf with the forecast that we receive from our sales team and you guys, our distribution channel and customers. So we should, whatever the pump products lead times are, we should be following. So typically I think we're still in the range of 5 to 7 or 7 to 10 days on many of these products.
Any other questions before we move on to the demonstrative point of this presentation? Okay, seeing none, let's change gears and go to the hands-on demonstration where we have two of our hydrovar X here in the studio with us. One is powered up, one is not, and I'll turn things back over to Derrick to talk about what we're looking at.
Yeah, thanks. So first, before we jump in to actually programming it, upon powering up, you should see this screen. So there's two options. The first one is going to say, press this center, enter button to go through the startup genie. Or you can skip the startup genie by hitting the multi-purpose button, the 3 dots here, and you'll go directly to the home screen and bypass the startup genie. But before we go through that, just want to kind of go over the screen itself. We have the 3 LEDs here. The top one is simply just a power indicator, right? So if this is lit up green, it means you have power going to the unit. Obviously, another way to tell if you have power is the screen. But maybe this is an indicator that if that screen's not showing anything, you could have a faulty screen or broken screen. An indicator would be that you still have this green LED going and the screen has failed. The middle one is your status one. So this can light up 3 different colors. Right now it's lit up red. This is indicating an error there. That's one of those blocking errors I was talking about, where it's going to shut down operation. You'll see it once we probably get going, but I can tell you now, I know what it is. We have a transducer wired to the unit, but there's not a real signal going back. It's not sensing a signal, so we're going to see a transducer fault there. This can also be yellow. That is one of those alarms, one of the less critical non-blocking faults there, so it'll keep operation going for you. And then lastly, you can see this green, and that would indicate that the pump is running. So there could be a time where it's alternating between green and yellow. That is just letting you know that the pump is running, and then there's an alarm going on with that as well. But red, it shouldn't alternate because that should be stopping any operation of the unit. And then lastly, this is your communication LED. So this can light up 2 different ways. Green, if it lights up green, that means that you are connected via a BMS or SCADA system. And then if it's lit up blue, that means you are connected via Bluetooth via the Xylem X application. And there are scenarios where you could be both. If you are tied into a BMS system and you are tied in via Bluetooth and your mobile application at the same time, it will just alternate blue and green to let you know you have both connections established. Some navigation buttons here. So obviously up, down, left, right, this enter button, the multi-purpose button. This is how you're going to get into the menu if you needed to dive into the menu structure. And then this, although it's a power icon, it can be confusing. This is not actually going to cycle power for you in any way. You would have to do that through a disconnect. What this is simply an on-off button. So this would let you stop the pump by clicking this or start it by clicking it. So think of this as a start-stop button. So now we're going to go through the Genie here. So I'll click the center enter button. So Genie, it's just asking us to pick language. We'll do English US. Now we have a few different options here. So there's single pump, and then there's 2 multi-pump modes. So there's serial cascade and synchronous cascade. So serial cascade is the last staged pump on in the system is going to run at multi-speed. The other ones are going to run at full speed. So if you have a 2-pump system and that first pump gets to running at full speed and it needs a second one to meet demand, that first pump is going to run at 60 hertz full speed, and that second pump is going to slow down or speed up to maintain the set point. Synchronous cascade works a little bit different. It's almost exactly as it sounds. All the pumps are going to work in a synchronized fashion. So whether there's 1, 2, 3 pumps on, they are all going to fluctuate at multi-speed, slow down or speed up at the same exact speed to meet demand. Some perks there, serial cascade. With that last pump slowing down or speeding up, what that's going to do for you is a little bit more accurate set point control. It's not going to overshoot or undershoot it while it's trying to speed up, slow down. It's going to be a little bit more accurate, but use more power as you got multiple pumps running at full speed. Synchronous cascade, this is a more efficient method where now you have all the pumps running at lower speeds to maintain constant pressure, so it's going to be more efficient, but you may have a little bit more of overshooting, undershooting a set point before it kind of stabilizes there. So for this, we'll do single pump. So it's just saying move to important parameters, just hit continue again. So now what kind of control mode are you looking for? We have pressurization or circulation. So pressurization is just constant pressure. Circulation would be that differential pressure that you're looking for. Closed loop, open loop versus closed loop applications. Pressurization. So what do you want to do now with the pressurization? I think majority of the time our users are using constant pressure, but as we touched on in the presentation, we got a bunch of different modes, whether it's constant flow, constant temperature, constant level, So we'll do constant pressure. What units do you want? If you did want to change something, if you didn't like PSI and you wanted feet ahead, you would click the enter button on it and you can scroll through. So you got feet ahead. You can change it to quite a few different things. We'll leave it at PSI. Similarly with flow, if you didn't want gallons per minute, there's several different options available for you to choose from. Or even later, if you wanted to change it, you can go back into the menus and change something there as well, but it gives you the option to tweak them right here in the Genie as well. So everything looks good there. We will continue. Basically, it's telling you what is the full scale of your sensor. So just so you know, we will be sending each unit out standard with a transducer. It's going to be a 0 to 300 PSI transducer, so that's why it's already defaulted at 300 PSI. However, if you did want to change it out to a higher rating, you can go ahead and scroll up to 0 to 500, whatever the full range of the sensor is you should be putting here. But like I said, standard out of the box, you will have a 0 to 300 PSI transducer, so that looks good. Here it's set the set point, so whatever pressure you're looking for in the system, we can, just for the example of the next one, I'm going to set this at 100 PSI constant pressure is what we're looking for in the system. So that looks good. I hit enter, it saves it. So this next one can be a little bit tricky or maybe confusing, so I'll explain it here, but it's set the start value after the unit stopped. So let's say that you have met or satisfied the system pressure of 100 PSI. There's no more demand, that pump or the VFD is slowed down to minimum speed, proved out, there's no demand, shuts off. This is saying, when am I going to wake back up? So it's in percentage base. So how much do I want the system pressure to drop before I restart? So basically 100% is once it drops to 99 PSI, it's just going to kick right back on here. We probably want a little bit of a buffer. So to keep math simple, I did 100 PSI. So if we did this at 90% of the set point, that means that there'd be a 10 PSI drop. So once the system pressure dropped from 100 to 90 PSI, that is when it's going to tell the system to kick on and try to get back to maintaining that 100 PSI. Minimum threshold, so that's disabled, but basically what this would, if you wanted it, it's almost what I'll call a broken pipe feature. So it's just going to protect the discharge end of the system. So it's saying, if I don't hit, and we can set it to whatever, 20 PSI, there must be something wrong in the system. And the next question is basically going to be, how long should it take me to get there? So if you don't hit 20 PSI in 5 seconds, there's some sort of issue and it's telling you to shut off. And the example, like I said, I like to give is a broken pipe. So if you don't have this on and that pipe breaks, it's just going to continue to pump at full speed, try to get up to your set point and never shut off. So if there happens to be a broken pipe, you give this kind of prove out thing and it's saying something's wrong, let me shut down so I don't flood a facility or something of that nature. Pipe fill mode, so just a nice way to fill the system up beforehand if you needed to. And it does ignore some errors. So similarly, right, if you wanted to fill it up, it's going to know that it should be ignoring any errors or that it's not getting up to pressure in a set amount of time. And then really after that, it's just setting your day, which is the 10th. And the years. I don't know what time. We'll make up a time. But really that's it. And now it's just giving you a system preview, letting you know what you pick. So single pump, constant pressure, analog input function. So it's just saying that since we did a pressurized system, we told it the 0 to 300, it's automatically expecting a pressure transducer in that analog input 1 port. So if everything looks good, you click continue. Now it's going to ask you basically, you hit the multi-function button, just go to the home page. Let's say if you weren't necessarily ready to turn on the system, then you would just do that. If you are ready to go, get the pumps running, you would click the power button, and this will actually turn on the pumps and motors to operate as you programmed them. So this would be your main dashboard. This is what an error would look like. So it's telling you an error. It's red up top. So we have two different errors. There's error E11, error E7. By clicking this enter button, it will let you explore the error a little bit more. So it's giving you, the date and time of the error, what it is. Error E11 is a sensor 1 error. So as I mentioned, I don't have a transducer hooked up to this, so it's not getting that 4 to 20 milliamp signal. It's seeing 0 milliamps. So notifying you that there's something wrong with the transducer. But like I said, if you wanted to click on it more, it might be hard to see here, but there's a right arrow info button. If you click that, it gives you a little bit more description of what exactly is wrong. So you don't have to just go by the name of the error. It'll actually describe what's going on to help you out a little bit more there. And then if there was something that you think you corrected or you wanted to clear it, you would hold the power button the 3 seconds to reset the error. It actually won't do it for this one because it's the transducer one's actually not it's a self-resetting one. It's only going to fix itself once the problem is resolved. I can't actually reset it on this one to show you. So back to the home page. So a couple unique features. So I'm looking at it upside down so you guys can see it properly. If you hold the enter button and up button simultaneously for several seconds, it will actually flip the screen. So if you are standing on the unit programming it the way I am, now I can see the screen properly to program it. And the up and down buttons switch as well. So this would now be up for me and down for me. But so now to switch it back so you guys can properly see, I would long press this and get it back. If you are in a multi-pump system and you wanted to force alternate the lead pump, so if you wanted to change it to pump number 2, you would long press simply the down button for several seconds, and it should change the lead pump in the system by doing that. So just a couple shortcuts that you can see right on the main screen. As I touched on, right, there's a few different main home screens, so I can click to the right to see. So this is constant pressure. This is my set point, that little widget. I'm on it. I can click it, and I can change my set point right here without having to go into the menu structure. And then lastly, auto start value. So once again, if I was seeing that pressure was maybe dropping too much for my liking or too little, I can go in here, simply change that start value, tighten it up, or expand it. So just, like I said, just some valuable information and widgets for you to interact with just on the few main home screens we have, and you don't necessarily have to jump into the menu group.
All right, before we move into the next part of the demonstration, we'll pause and see if there are any new questions. But I do have one that we do need to pick up. So Derrick, the question is, who is the best point of contact to convert an old style hydrovar to a hydrovar X? So a couple of layers there. What's the best way to contact if you're specifying and pricing a hydrovar X? And then talk a little bit more about converting a hydrovar to a hydrovar X.
Yeah, so we have a controls tech support team already established. So that team should be trained and ready to support you guys in the field, whether it's troubleshooting or pre-sales type of questions on crossing over, quoting, so on and so forth. So I can shoot out maybe an email address for you. I believe it's like AE_presales@xylem.com, or conversely AE_postsales@xylem.com. So that group is now trained on these VFDs as well to help you out. You can always reach out to myself, being the product manager of the hydrovar X solution, or if it's already paired with a specific pump, whether it's the ESV, ESH, so on and so forth, you can reach out to one of those product managers who manages the complete pump portfolio as well to assist you.
Additionally speaking, your field sales rep or market development manager for the region that you're in, who should be familiar with, can also help with this as well.
Great.
Any other questions to put in through the chat at this point? All All right, then I'll just make one comment that, Derrick, your hands look very nice. That's something that came in. So please feel free to move forward with the next demo.
I have other career options, maybe. No. Yeah, and we can go ahead. So the multi-purpose button, so you'll see maybe in the bottom right corner here, we have, it's the menu button. So if you did want to dive deeper into the menu group, it's going to automatically ask for a password. The standard password on this is 066. You can change this out in the field if you want to, because this is a generic one. So if you're familiar with our VFDs, then everyone knows the code, but if not, it's up to you. But here, there's 9 different menu groups. So there's just the home menu, error log, pump information, pump control, your inputs, output settings, multi-pump, inverter, communication, general settings. So really, maybe some of the important ones, one caveat I'll share, I guess, to start is there's no way to get back into the Genie as it stands today. This is a product improvement I'm already trying to work on, but to give you kind of the heads up in the process it goes today, menu group 9 are your general settings. Then there's factory settings. The only way to get the Genie back up is this commissioning complete currently says yes. That is because we went through the Genie. I would have to change this to no and then cycle power, and that Genie would pop back up. If I don't change this to no and I cycle power, the Genie still will not pop up. It'll take you right to the main home screen. Another way to do it is factory restore. I could flip this to yes and then cycle power, and then it'll bring the Genie back up as well. So the difference here, commissioning complete, is just basically going to reinitialize the Genie for you, keep all the parameters and settings that you previously had. A factory restore is going to wipe out anything you had. And you're basically starting fresh, and it's going to bring up the Genie again. So factory restore is good. That's almost our first recommendation. If you're having troubles with a drive and you just can't quite figure it out and you've been changing parameters, or you think someone's messed around with it, we always just recommend wipe it clean, start fresh, go through the Genie, and a lot of times that will fix the majority of the problems that you'll find. Going back out, a little workaround as well to the Genie. So menu group 1, home menu, application. You'll notice these are actually all the same questions that were asked of you in the Genie. So you can go through here and do it. It's just not guided. So you would have to literally go through every single one and change whatever you wanted. So this is essentially the Genie. It's just not, step by step for you. You would have to go through each parameter individually to do there. So in a sense, you can get back to the Genie, but not perfect. Sensors, this would be where you would, if you were going to add additional sensors or you wanted to change anything there. Actually, yeah. Pump control, so configuration, set points. Nothing crazy here. What else do we got? Communication is where it's going to come standard at Modbus RTU, like I mentioned. But this is where you would set up the specific parameters associated with that. Wireless communication. So I always get this question a lot, just in case someone asks. They always wonder if you can turn off the Bluetooth capability, kind of like a cybersecurity type question. So you can go in here, turn this to off, and it'll prevent anybody from connecting to the unit via Bluetooth. And this menu group is password protected. So there's a couple layers of protection there if you didn't want Bluetooth on. Oh yeah, let me do that. So let's say you didn't know what something was. So pressurization, I mean, it's simple. We know what it is. But if I hit this, you'll see on the screen, you won't see. So if you hit the right arrow button on the screen over any parameter or setting, that gets you to that description I was talking about. So it's just going to give you a little bit more detail on what each parameter or setting is. So pressurization for open loop systems, boosting water pressure at a high building, or circulation for closed loop, as we touched on. So it's just going to let you know a little bit more detail of what exactly each thing is there. Going back home, the multi-purpose button, long pressing that's what gets you into pair mode. So once it's flashing blue, it's telling you that now with your Xylem X app, you can connect to it. Not sure what else to go over. If we're looking here, the power's off on this one, so safety reasons, but this is where you would do your wiring. So you're going to take off.
Question
Yeah.
while we change the camera angle so we can see the second drive as well. Question that came in, how many drives can be paired in a multi-pump system?
Up to 8 pumps. So you can go up to 8 pumps there. We're good?
I have one more question. After setting up a drive, can the parameters be copied and downloaded to then be uploaded onto another drive to duplicate the parameters for another drive setup?
Yes.
So I think the question is, how do you do that?
Yeah, so that's with the Xylem X app that I was talking about, where you can download basically and upload CSV files. You can simply program one, take it, and then re-upload it into another. If you're doing a multi-pump setup, unfortunately I can't really show you that today, but you strictly do the setup all in a single VFD, and it's going to automatically address all the other pumps as pump 2, 3, 4, 5 in the system and copy the parameters that you set in VFD 1. So you don't have to do it for each pump in a multi-pump system, but if you have an application that mimics another one that you did out in the field, then that would be an opportunity or reason why you would download and re-upload into a different VFD. But as far as the same multi-pump system, you don't have to download it or reprogram each VFD individually. You just go through the one itself and it automatically copies the rest of the parameters appropriately. So now this is the cover. As you can see, there's a lot of space here. You're removing just 4 different screws to take the cover off to get into the wiring here. A lot of space for you to interact with. This would be the power supply. You're seeing these cables go into the unit. So you have your 3-phase power, right, and the ground going in there. L1, L2, L3 ground. It's labeled for you here. We got a bunch of ports along the side of the VFD where all the wiring will go through, and they come up through the side. So your power wiring's running there. This is your pressure transducer, so it's clipped in here. You will see this is analog input 1, where it's pre-programmed for that 0 to 300 PSI for pressure applications. And then here I ran a communication wire. So a couple perks with our communication wiring is we have plenty RS-485 ports. So we have a bank set for BMS or SCADA systems. So you can see 31, 32, 33 here, and you got some ports here. And each VFD has to be daisy chained together. So instead of cramming 2 sets of wires into the same terminals and going to the next one, we basically have an input and output going. So there's just plenty of room and strips there for communication. And then conversely, right next to it, these are our multi-pump terminals. So 28, 29, 30. This would be, let's say VFD 1. So I have it in B, A, and C. It'd be going out to pump 2. And then in pump 2, if you had a triplex, for example, you would see input wiring here, then another set going from VFD 2 out to 3. So just giving you plenty of space and room for communication wiring. We have a few jumpers here. It's just your run-stop jumper. It's automatically put in there, but let's say you wanted like a float or some sort of run-stop signal, you would pull this jumper. It'd be normally open and closed there to stop or start operation of the unit there.
Derrick, quick question about wiring. Do you recommend using stranded or solid wire? Does it not matter?
Yeah, I believe stranded is the preferred. It is listed out in the IOM. I can get specific details from engineering on what their recommendation is. But yeah, stranded is the route to go. I believe that's probably everything for hydrovar X if there's not any other questions, comments, or...
Any other questions for hydrovar X before we pivot to optimize? Okay, once again, please feel free to keep adding questions to the team's chat, and we can circle back to hydrovar X, but for this next portion, we're going to pivot to the optimize, which will be more of the PowerPoint type content.
Thanks. Good. Thank you. All right, moving right along to optimize, which is our condition monitoring sensor. Just some high-level overview. Here, it's just, you know, what we call a cost iceberg, similar to an iceberg, right? You only see a small portion of the iceberg on the surface. Well, really underneath, there is the majority or a whole lot more iceberg under the surface. So similar with the cost of maintenance, I think traditionally people look at just labor and material costs associated with that and overlook some other hidden factors associated with maintenance costs, such as higher energy consumption as something begins to deteriorate more and more. Safety risks, environmental issues as something potentially fails, so on and so forth. Here, just a slide I like to go over is what I view as the three main maintenance strategies out there. There's corrective maintenance, which is fix it on failure. So basically, you're just waiting for that asset to fail. It's no longer operational. Now action is needed to get that product back up and running. This tends to become an emergency. We need to rush things to get something back up and running. And then preventative maintenance is kind of on the opposite. You're maintaining stuff on a fixed schedule. So you're doing this to basically maximize uptime. I'm going to change out, you know, a seal or whatever it is every 6 months because I know it's not going to fail in that time frame. And we just want to make sure we're staying operational. And then lastly, we have predictive maintenance, which is based on the actual condition of the asset. So we're going to notice some deterioration and then take action while we still have some time to avoid downtime. So for viewing these three, corrective maintenance can cost up to 10 times more than predictive maintenance, and then preventive maintenance can cost up to 5 times as much as predictive-based maintenance strategies. So here we have a PF interval chart. If you're looking at it, you'll see that green star there. That's the P, which is potential failure. Basically anything to the left of that green star is a brand new product, right? We know that it's in perfect health, it's good. Over time, it's gonna start to wear. As we move right of that green star, right, we might start to see some wear of the unit. The far right, we have the F, that is the failure, actual failure of a unit. It's downtime now, action is required to get it back up and running. So the idea of optimize is to detect potential failures, right, before we reach that, so functional failure. So essentially, we want to make sure that that product or asset is starting to deteriorate before we take action, but also give us weeks, days, months before an actual failure happens. And it's doing that by monitoring changes in vibration and changes in temperature. And then you see the blue and red arrows going across. That's just telling you the longer we leave a problem to brew, it continues to get worse. So now it becomes less efficient, or it starts to use more energy over time, and the cost to repair that problem becomes more costly as well. So here's just a high-level system architecture of the optimized solution. So kind of the bottom left, you'll see the optimized sensor itself mounted on a bearing housing here, for example. And that is taking the temperature, vibration readings of the bearing housing. It's pushing that out via Bluetooth. So there's two ways that this communicates. Both are via Bluetooth, but the one is to a user's mobile device. So someone has to be within Bluetooth range of the optimized sensor to collect data. I'll call this almost a maintenance round. So a user with their mobile device would have to go within 100 feet of all sensors, collect the data, and then their Wi-Fi or cell signal is going to push the data to the cloud and update everybody else's mobile application with the most recent data. However, if they don't want to have someone do a maintenance round, or it's a truly remote area where someone can't, then we would recommend installing the optimized gateway. That would be installed within Bluetooth range of the optimized sensor. It's going to collect those pressure and vibration readings, and then via basically a mobile subscription, LTE-M, it is going to push out the data to the cloud and update everybody's mobile phones. And then the top, which we already kind of talked about, is the Avenzer smart monitoring platform. So Optimize is strictly a mobile application. There's not a web-based platform. We are using Avenzer as that web-based platform, which can consume the optimized data as well. So now not only can we monitor our VFDs in that platform, but we can pull in temperature, vibration data of a pump housing, bearing, motor, whatever it may be, all in a single dashboard now. And then the bottom, very bottom image you can see exploded is a pressure sensor. So we have Bluetooth pressure sensors that we can install in the system. So whether you want to monitor suction pressure, discharge pressure, differential pressure across the pump, you can do that. And it's going to communicate that pressure reading via Bluetooth to the optimized sensor. And now we can collect vibration, temperature, pressure readings with this solution here. So this is a similar slide to the previous one, just looked at a little bit differently. So if we're looking at the categories on the left, for example, condition monitoring, these are the assets or components that we would need to get these benefits. So condition monitoring, right, with just using the optimized mobile application and the optimized sensor itself, we get graphical trending, instant health guidance, right, getting that temperature and vibration readings. There are pre-built-in standards. There's ISO and ANSI HI standards around vibration and temperature levels for pumping applications. So you don't necessarily have to understand vibration limits or anything like that. They are pre-programmed in here. Those thresholds are in there for you, and it's going to alert you once they're passed. There's maintenance reminders and logs that you can program in there, and then report generation. So maybe if you don't understand what's going on in there, you just need someone else to review it. You can pull up a single PDF file with all this information, send it to somebody in tech support to take a look at the information for you and maybe assist with letting you know what exactly is going on. To take it a step further, like asset lifecycle management, that's basically just introducing the Avenzer smart monitoring platform there. So a few benefits to Avenzer. It's a web-based platform, so now you don't only have to look on your phone, but you can pull up your laptop or computer, access that information there. Avenzer monitors other equipment, which I touched on, so not only are you getting temperature and vibration readings on an asset, but now we can pull in our VFDs and do some read-write capabilities and get a lot more information. So that's why I was calling it almost a BMS Lite, where all of your assets can be monitored in this single Avenzer smart monitoring platform. Connection to BMS and SCADA systems. So if a customer already has their own SCADA or BMS systems established and they're comfortable with their own site dashboards, Avenzer can communicate to that. So now they can pull in all of that information into their own site dashboards that they're already comfortable with and get all the same information. And then lastly, Avenzer is a little bit easier to share data. So something I didn't touch on, with the optimized solution, whoever wants, if we're just using the mobile application, whoever wants the most recent data has to have had physically paired with the sensor at one point. So if someone's out of state and there was no way for them to get in front of the sensor and physically pair with it, there's no real way for them to get up-to-date information automatically. You would have to pull a report and send it to them that way, unless they physically paired. Where Avenzer, you can share access to a specific site or station by username. So it's a little bit easier to share that information and give up-to-date information.
Okay, we do have a question. What is the reading frequency window for the pressure sensor and also the vibration sensor?
Like the range? I'm assuming they're talking about the Bluetooth range? Or what is the reading frequency?
The reading frequency window is the question. So I think it's how often are the readings being taken?
Yeah, so that's programmable. So I believe it's going to be preset in the application as every 15 minutes. However, you can tell it to take readings every 5 seconds to every 24 plus hours. So that is all based on whatever your preference is there.
And will it have any impacts on things like battery life?
Yes. So that is, you'll see in one of the upcoming slides, but we say a rather wide range of battery life, anywhere from 3 to 5 years, and that's just all around how often you're taking readings. So if you're taking readings every 5 seconds, right, you're going to be closer to that 3-year window. If you're taking every 24 hours, you're going to be closer to that five-year window. The battery is replaceable though, but yeah, so 3 to 5 years, I'll say it's all dependent on how often you're taking those readings. And then lastly, the remote monitoring. So just adding the optimized gateway to the solution. That is just giving you that true remote monitoring capability. Someone does not have to be within Bluetooth range of these sensors to get the data. This gateway would serve that purpose and then send out the data for you. So a bit of a modular approach. You don't have to use all of these things together, but you can piecemeal it to get whatever benefit you want, or you can use everything together to take full advantage here. So a bit of the sensor overview. It is 3-axis vibration measurement there. There is an infrared non-contact temperature measurement there, so you can't see it on this slide on the image, but in the bottom center of the optimized sensor, that is where that infrared non-contact temperature is taking those temperature readings. This is NEMA 4, so it can be used outdoors. As I touched on earlier, there is a replaceable battery. It has that 3 to 5 year life. However, on the cover, there's 4 screws you can unscrew, then a couple more screws on the battery. You can swap it out, you're back up and running. No data is lost once that battery dies. The only data that's basically lost is it's not taking readings from the battery's dead. What else? Magnetic mounting, so standard mounting, there's going to be 4 magnetic feet on the bottom of the sensor. You can see 2 of them kind of shown there, hanging off the sensor there. If it's not a magnetic surface or you just want a bit more of a solid insulation, we do have a fixed mounting bracket so you can bolt directly to an asset. And then we have some custom magnetic feet which are a little bit better suited for very tight curved surfaces. So the standard magnetic feet still can support curved surfaces as long as 4 of those feet are, all 4 are still touching the asset. These are very strong magnets. It will be hard to take them off of an asset, but when it comes a very tight surface, we do have another magnetic mounting approach that's a little bit better suited. Here are some pictorial instructions. It's sent with each sensor that goes out the door. There are descriptions associated with this as well in the actual literature piece that you'll get. But to quickly run through, step 1 is basically just telling you download the optimized mobile application. Step 2 is saying register for the application. And then 3, take out the sensor. There's going to be a screwdriver shipped with each sensor. On the back of the screwdriver, there's a little magnet. The magnet's important because that is how you wake up the sensor and how you put it in configuration mode. So you'll hover that magnet over the little LED or Bluetooth icon on the top right of the sensor. You hover it until it flashes pink. Once it's flashing pink, it's letting you know that it's in pair mode. You'll take your mobile phone, scan the QR code, or you can manually put in the serial number. So under the QR code, there'll be a serial number. You can type that in as well. Once you do that, the LED should flash blue. That's letting you know that you properly paired to the sensor. If you don't see that flash blue, then something went wrong. There is a time limit on the pair mode. So if you're not quick enough, hovering that magnet over once it's flashing pink, it will stop flashing. You can't pair. But it is, I think, about a minute, so it should be fairly easy for you to get it done. And then step 7 is just telling you to configure the optimized sensor. So basically it's going to ask you, what am I installed on? What standards do you want to follow? How often do you want to take those readings? So on and so forth. Then the optimized gateway. once again, communicating via Bluetooth to the optimized sensors. These have to be installed within 100 feet of the sensor. You can pair up to 6 optimized sensors with a single gateway. So a couple of scenarios where you may need an additional gateway. Let's say you have more than 6 sensors in a single room, then you would need an additional gateway. Or if you can't install all 6 optimized sensors within 100 feet of that single gateway, then that would be another reason why you would need to introduce an additional gateway to the application. External communication, it's communicating via low power wide area network. So there's 2 forms, LTE-M and narrowband IoT. There's nothing customers have to do or be aware of necessarily. It's just different countries use different forms or have both. It's going to automatically search for the strongest signal and connect itself. Low power wide area network, the benefits there, it can take very small, much smaller data packets and push them out, and it has a little bit better penetration through walls. So a lot of these will be installed in basements, mechanical rooms, so on and so forth. So although you may not have cell service, doesn't mean that this gateway wouldn't work, because it's using a different kind of network that's better for those types of applications. There is a power supply associated or needed for the gateway. It's just a 5-volt USB micro power supply. That's how it's powered. 1 button pairing, which we'll get into. Something I didn't touch on the previous slide actually. We do have an optional power supply for the optimized sensor as well. So if you are near an outlet, you can plug in this power supply and actually never have to worry about battery life as well. But if you're not near a power outlet or you don't want to go that route, then we have that 3 to 5 year life, and the battery needs to be replaced once it fails. Here, more pictorial instructions for the gateway, pretty straightforward. Step 1, it just comes with 2 antennas. It's telling you to screw in the antennas. The ports are actually different sizes, so you can't get it wrong. You're gonna get it right there. It's telling you to plug in the power supply in step 2 and hit the power button to turn it on. You're gonna go back to the optimized sensor that you wanna pair to the gateway. You're gonna hover that magnet over it to put it in pair mode. Once it's flashing green or pink, you're simply going to click the Bluetooth button on the gateway. Now both LEDs on the gateway and the optimized sensor should flash blue, once again indicating that you successfully paired the devices together. And then you're off and running. That's all you need to do. And
Quick, another question. So is equipment runtime an easily accessible data metric? Is it accessed on the app using the data from the vibration sensor?
No, so you're actually not getting runtime with the sensor, because there could be times where it's not going to fully capture that, depending on how often you're taking readings, right? If it's every 15 minutes, 10 minutes, whatever, it's not necessarily capturing runtime the best way.
Okay, so the second half of this question, is there a way to dive into daily, hourly data for the sensor to see how long equipment ran during a shift? Is there a way to accomplish that?
No, unless you're gonna, honestly, the only way is if you reduce how often you're taking readings, right? You turn it down to seconds, minutes, and then if you look at the vibration data, right, you're gonna get it in graphical trend history, and vibration should be much higher on the unit while it's running versus when it's off. So looking at the chart, you should clearly see based off of vibration levels when it's running versus when it's not. Like I said, it's just not the perfect indicator because it's not constantly taking readings to pick it up. So if you have that frequency too large, like I said, there could be opportunities you miss when it was actually running versus when it wasn't. Then lastly, we have the pressure sensor. So once again, communicating via Bluetooth to the optimized sensor. This has a similar Bluetooth range, has to be within 100 feet of the optimized sensor to properly communicate. You can measure pressure or differential pressure. Replaceable battery, you unscrew the top of that pressure sensor there, you'll access to the battery, you can swap it out there. And then standard mounting with this is a 1/4 inch MPT male thread. And here, instructions. So basically the asterisk or the first step there is telling you need an optimized sensor in order to use the pressure sensor. Step one is telling you on the main dashboard of the Optimize application. In the bottom right corner, there's going to be a plus sign. This is how you add any Optimize sensors or pressure sensors to the dashboard. You would click that. It's going to ask you, what are you adding? You would pick a pressure sensor. It's going to ask you to scan the QR code of the pressure sensor. Then it's basically going to say, what are you looking to measure with this pressure sensor? If you just do suction or discharge pressure, then it's going to ask you to scan or put the Optimize sensor in configuration mode. However, if you pick differential pressure, it's going to ask you then to scan the QR code of the second pressure sensor that you will be installing in the application. Then you would proceed to step 4. Like I said, put the Optimize sensor in configuration mode. Once it's flashing pink, you would scan the QR code of the Optimize sensor itself. And then once again, you should see LEDs flashing blue on the Optimize sensor to let you know you did everything correctly. Some screen grabs of the mobile application. So the far left, the first 2 screen grabs actually are your main dashboard. So there's 2 different views. There's a list view, which allows you to take pictures of the application or what the Optimize sensor is installed on. You can name it. So a couple examples there, right? Cooling circuit pump, pressure booster, so on and so forth. Or you can flip it to map view. Map view is just simply showing you where you have Optimize sensors installed. But going back to that list view, everything here is traffic light indicators. So what I mean by that is you can see these little icons of sensors under each pump. If it's green, everything's good. If it's yellow, that's kind of a caution, something less critical. And if you're seeing red, that's a critical alarm or error that's going on there. So you may just pull up this application, look on that main dashboard. If you're seeing everything green, that's as far as you go, right? You got your peace of mind. You don't need to know anything else. If you're seeing something that is yellow or red, you're going to want to look into it a little bit more. In the top right corner, you're going to see a little bell icon. You click that, you're getting the far right screenshot there. It's just going to let you know what exactly happened. Vibration, what access, what the reading was, date and time associated with that. And you can go in and acknowledge them or whatever it may be. However, if you want to dig into them in a little bit more detail, you would click on the specific sensor and you can start to see more information. But before I do, I don't have it shown here as a good example, but you can have multiple sensors on a single asset. And if you did, instead of having one Optimized sensor icon, there would be 2 or 3 side by side letting you know, right? So if you're monitoring a bearing housing and the motor, for example, right, that would be an instance where you have 2 sensors on a single pump application, then it would just show you 2 icons there side by side. Or if you introduced the pressure sensors, there would be a little pressure sensor icon there as well. But like I said, if you clicked on the specific sensor, it would take you to these screens. So the first one on the far left would be this first screen you see, and that's just giving you the latest readings that were taken. So once again, you can see temperature in a specific value, vibration, specific values. Once again, traffic indicators. If all these numbers are green, that's as far as you maybe want to go. You don't need to do anything else. Yellow or red, you want to investigate more. You can click the view trend button and it's going to take you to the second screen grab there. And that's just basically a graph of every single reading ever taken. So up top, you can see 2 calendars. You can narrow or expand the time frame of data that you want to take a look at, which is nice. You have the ability to change to a couple other different readings. So RMS is the main one, but we do have an FFT chart there, which is basically just taking vibration counts or readings in the frequency domain, which can be helpful where if you're seeing a bunch of vibration or this heat map of purple dots all in the 60 hertz or first harmonics, or let's say you're seeing it at second harmonics at 120 hertz, it could be indicators of specific problems such as bent shaft, cavitation, so on and so forth. So it just helps you out a little bit more to pinpoint what exactly is going on aside from saying you're at high vibration levels. Going back to the first screenshot, you can see kind of towards the top, it says last updated on, so it gives you the date, time. So if that wasn't recent enough for you, you can click the force read button on the bottom. It's going to take readings and refresh that information for you. Another good indicator that, if you're worried that the gateway or something's not working anymore or properly or something, you can look at that last updated on. So right now in this screen grab, it says local. Local means that I collected collect the data via making a maintenance round, right? I went in within 100 feet with my mobile device and it took that data via Bluetooth. If the gateway pushed the data to the application, it's going to say cloud. So if you're seeing that the last update was via cloud, that means that your gateway is the one that gave you the data. Then a vendor, like I said, a vendor has the capability to pull this in, so we've already gone through a lot of this information. These are similar screen grabs that I showed you. A vendor OPC, that is how you connect to a user's BMS or SCADA system. I won't get into the specifics to that, but we do have a website, xylem.com/Avenzer, where you can find more information. There is a user guide and a white paper kind of going through the process on how you would connect a vendor to communicate with a customer's SCADA systems. So that's the high-level overview of Optimize. Are there any specific questions, comments that you have on this particular product? Okay, well, I think we'll go ahead and then wrap it up. You'll have a couple minutes to shoot a couple questions potentially, but if not, really appreciate you guys taking the time to join us today and review hydrovar X and Optimize. Thought it was a great training, but please send us your feedback or any questions you think of in the future. Don't hesitate to reach out. Once again, thank you for joining us. Really appreciate it.
And I'll echo that. Thank you again for your attention and interaction during today's training. Please feel free to contact your Xylem sales point of contact for any additional questions, help specifying, or to price or order either of the products that we went through today. And then on behalf of Derrick, Sarah, and I, until next time, take care.